Okay, today we are going to be diving into tips on solving one variable equations. I've come up with a list of things you can kind of go through and check to make sure you're doing. First one is the jump, so which is the distributive property. So if you have the distributive property, you can do that first. Next is to combine like terms on either side of the equal sign completely. And then you're going to move your x's to one side. You might be using a different variable, but I'm just going to say x's here for now. Then you're going to try and get x all by its lonesome self, so you want to move any constants that are there to the other side. You're going to do all this moving by either subtracting or adding the opposite to create a zero, which is essentially going to get rid of it on one side and move it to the other. And then you'll divide or multiply to get x all by itself. And then there's three things that can happen. You can either get no solution, you can get true for all numbers, or what's going to happen most of the time is you're going to get an answer that you're going to want to check to make sure you got it right. Now keep in mind, the golden rule for solving equations is what you do to one side, you always got to do to the other side so you can keep the balance in order. Remember, these are equations, so they must have an equal sign. Sometimes I get students that try and solve an expression, which is just a mixture of constants and variables, various operations, and you can't solve that if it doesn't have an equal sign. When it has an equal sign, then it becomes an equation. Okay. Another thing to keep in mind is we're going to leave things in descending order all the time. So first problem, 9x plus 12 minus 2x is equal to 10x plus 3x. So there's no distributive property to deal with here, so we're going to move on to combining like terms. This is an x term and this is an x term, so when we combine those, we'll get a positive 7x plus 12 is equal to 10x plus 3x. Oh, I guess we could have combined those two. So these are also x terms that we can combine for 13x. Okay, now we're going to move our x's to one side. Right now they're on both sides, so I'll subtract 13x from both sides. Notice how I put the x term underneath the x term so I don't accidentally add it to a constant. So here I'll get negative 6x plus 12 is equal to 0. Anytime everything goes away on one side, you're going to have to put a 0 there as a placeholder. Now I'm going to move my constant, so I have plus 12. So to get rid of the plus 12 on the one side, I'll subtract 12. But what you do to one side, you got to do the other side. So this makes a 0, and it goes away. So I'm left with minus 6x is equal to negative 12. Last step is to divide or multiply. So in this case, I'm going to divide by the leading coefficient, which is minus 6. I do that to both sides, and then I'm going to be left with x is equal to 2. So I think that's my answer, but I'm going to do a check to make sure. So to do a check, I just plug the answer I think is correct back into the original equation. So I'll have 9 times 2 plus 12 times, plus 12 minus 2 times 2. And we're going to see if that is equal to 10 times 2 plus 3 times 2. Well, 10 times 2 is 20 plus 3 times 2 is 6, so we're looking to see if we can get all that to equal to 26. Here I have 18 plus 12 minus 4. So we'll get 30 minus 4 is equal to 26. So 26 does equal 26. So we get a good check, which means this answer is correct. All right. I got 3 plus 2x minus 3 times x plus 1 is equal to 3x minus 8. So here, distributive property first. So since I can take this negative 3, I'm going to do a jump. This stuff here, I'm just going to do or rewrite it. So minus 3 times x gives us minus 3x. Minus 3 times 1 is minus 3. That equals 3x minus 8. Next, I'll combine like terms. So here I can combine these x terms, which gives me minus x, and then plus 3 and minus 3 go away, cancel each other out. So minus x is equal to 3x minus 8. I have x's on both sides still, so I'm going to try and get them on one side. I'll do that by subtracting 3x from both sides. And then this will go away. I'll be left with minus 8 there. And here's minus 4x. I'll divide by the leading coefficient, which is negative 4. So x equals 2. Plug back into the original. 3 plus 2 times 2 minus 3 times 2 plus 1 is equal to 3 times 2 minus 8. So on this side I have 6 minus 8, which makes negative 2. Over here I'll get 3 plus 4 minus 3 times 3. 3 plus 4 is 7 minus 9. Negative 2 equals negative 2. It's a good check, so my answer is correct. All right. Minus 3 plus 2x plus 7 plus 6x is equal to 2 times 4x plus 2. All right, I can combine like terms for 8x and then plus 4. I put the x term in the front just out of habit of leaving things in descending order. I always want the highest power variable first, and then last would be the constants. So distributive property here gives me 8x, 2 times there, and then 2 times 2 makes plus 4. Subtract 8x from both sides, so I can move them over to get them on one side. That goes away. Well, it turns out this goes away too, and I'm left with 4 equals 4. So when this happens, assuming I did everything right, if you get a true statement like that, then you can say that it's true for all numbers. Or you can say that there are infinite solutions. So this isn't going to happen all the time, but it's something that can happen. So no matter what number you plug in for x, you're going to get the same answer. If it was on a graph, then the two graphs of that line would be exactly the same. All right, minus 4 plus 2x plus 2 is equal to x plus 1 plus x. Combining like terms, we'll get 2x minus 4 and 2 gives us minus 2. Over here we'll get 2x, combine the x terms, plus 1. I'll subtract 2x from both sides, and then that goes away. Well, so does this, and then I'm left with negative 2 is equal to 1. Now, here's a little different situation. Negative 2 does not equal 1. I'm going to check to make sure I did everything right. Looks like I did. So I'm going to cross that equal sign out and put a does not equal negative 1. I'm saying that I know that negative 2 does not equal 1, and therefore, so 3 little dots like this means therefore, there's no solution. So it doesn't happen as often. Usually you're going to get an answer and you're going to check that answer. But the two other things that can happen are no solution and infinite solutions. If this was a graph, then and there was no solution, then you basically have a graph of a line that's parallel to the other graph, and so they'll never cross, so there's no one solution. All right, 2 times x minus 9 is equal to 3 times x minus 6. So distributive property I got to do twice. Jump, 2 times x is 2x, 2 times negative 9 is negative 18. 3 times x gives us 3x. 3 times negative 6 is negative 18. I'll subtract 3x from both sides. That's going to go away. I'll be left with minus x minus 18 is equal to minus 18. Then I'm going to add 18 to both sides. And then minus x, this will go away. And this becomes 0. Now, 0 is an answer. So don't think that that's no solution. Oftentimes people get 0 and they think it's a no solution, but last step would be to divide by negative 1 to get x by itself, because there's a 1 in the front of that. But and then you're dividing by the same thing, so you can form a 1 and get x by itself. There'd be a 1 here that we don't run on where we don't need to write it. So it's just x is equal to 0. When you have 0 in the numerator, it's just x equals 0. Now, before I box my answer, I want to double check my solution. So 2 times 0 minus 9. Here's my check. 3 times 0 minus 6. So here I'll get 2 times negative 9 is equal to 3 times negative 6. Negative 18 equals negative 18. I know I get a good check. Now I can box my answer. All right. Minus x plus 4 is equal to 5. So this is one thing that throws people off sometimes when there's a minus sign in front. It's really like having a -1 in the front that you need to use the distributive property on. So you just got to distribute that negative sign throughout. So it's -1 times x, which is minus x, -1 times 4, which is minus 4, and that equals 5. Get the x term by itself, so I'll add 4 to both sides. That makes it 0. Minus x equals 9. I need to divide by -1 to both sides, so x equals -9. Do my check. Minus, got -9 plus 4 is equal to 5, minus times -5, whoops, -5 equals 5, so 5 equals 5, and I get a good check. Now, let's say, for example, to show you how a check can work to tell you got the wrong answer. So let's say we forgot to divide by -1 or switch the signs, and we just thought that the answer was 9. And if we think x is equal to 9, and we plug that in, then you're going to get 9 plus 4 is equal to 5, and then you'd have minus 13 is equal to 5. So 13, or -13 is equal to 5. And that's not true. So you'd be scratching your head going, okay, I'm not getting a good check. What did I do wrong? Hopefully you can go back and find your error where you made your mistake and you got the wrong x value. Well, it looks like you forgot to divide by -1, which is going to mean that x is equal to -9. And then if you went back in here and changed everything on your check, you would discover that you did make a mistake, and hopefully you get a good check. And then you would know that the correct answer was -9. All right, so just to review, follow these guidelines. Check to see if there's a distributive property first. Combine like terms on either side of the equal sign. You're going to try and move your x's to one side or the other. Move your constants. All right, all this happens by adding or subtracting the opposite. Or just add the opposite of what's there, and then it's going to create a 0. And eventually you're going to get the variable by itself equaling something. The last step would be to divide or multiply by a number that's going to create a giant 1 and make that x be all by itself. Other things that can happen, you can have no solution. You could have infinite solutions. And then you always want to do your check to make sure you have the right answer. Why go through all that work and not get the right answer? Okay. If you get a bad check, go back and find your mistake until you get a good check. All right, hopefully this will help you. You don't have to do things necessarily in this order, as long as you follow the golden rule, which is always what you do to one side, you have to do it to the other side, so you don't disrupt the balance of the equation. All right, good luck with all that.